Hello everyone, it's Mr. G and I'm here to bring you the fourth lesson on our beginner's Java tutorial. And today we're going to be doing some math stuff. I know, fun. But I'll try to make it as painless as possible. It's not too bad. And some of this stuff is actually really important. So let's go ahead and get right into it. So the first thing I'm going to talk about is the modulus operator in math or in programming. I have not actually come across this in math, but I have come across it in programming and it can be useful sometimes. And what the modulus operation is when you divide two numbers, but instead of getting the quotient, which is the answer for a division problem, you take the remainder instead. So to show you example, and x equals, let's say 89, and y equals 5. All right, now normally on a division problem, you would divide these and you would get, uh, what's that, 17.8. But we're not going to get that answer because we're going to be getting the remainder instead. So int z equals x modulus, and it's a percent sign, y. Okay, and then we can print, if I can type, z, print z out, whatever the value of z is, and that's based on these variables that we set here. Now, 5 goes into 89 17 times, and that's going to give you an answer of 85. But we're not going to get that 17. We're going to get the remaining 4, the last 4, and there it is. So let's take a look at why that happened, because that can be a little confusing. So 89 divided by 5 equals 17.8. Okay, but we're not doing division, we're doing the modulus. So, but okay, it goes into, 5 goes into 89 17 times evenly with as an integer. So that equals 85. So 17 times 5 equals 85. Now we need to get the remainder though. So we have 89 minus 85, and that gives us 4, which is why we got that answer. So I hope that makes sense. Modulus is essentially you're getting the remainder instead of the quotient. Okay. Now speaking of quotient, and this is the perfect couple numbers to test this with. Java math in Java can be a little interesting. It mostly mirrors real math, but sometimes it does things a little bit differently. So when you have two integers and you divide them, you're going to get an integer as a result. So let's take this and x divided by y. Okay, so the answer to this is 17.8. Okay, 5 goes into 89 17.8 times. Now, when I execute this code here, that's not what we're going to get. We're going to get something a little different. We're going to get 17 because remember, an integer is a whole number. And that's what we're going to get here. We're dividing two integers. And so the answer is going to be a whole number. And the greatest whole number that goes into 89 when we're talking about dividing by 5 is 85. So this is going to chop off this 0.8 and this is going to give us the 17. So it's essentially this expression here. So we have to be careful about that when we're making calculations, especially if they need to be precise. Um, we'll have to do something different. Now, if you have two integers and they need to be integers, but you want to accurately get the result when dividing them, you would you can turn one of them into a float or a double, You can do that in one of two ways. You can just store them as doubles to begin with, or one of them is a double, maybe. And then when you uh, evaluate this, it'll give you the correct answer because Java will automatically convert any integers to doubles when doing math with doubles in the same expression, like we're doing here. But you can also um, do something that we call casting. I'll talk about this more in the future, but you would basically put the data type in parentheses in front of the variable that you're trying to cast or the value that you're trying to cast. And so it will basically convert this into a double for you, and it'll essentially give you the same answer. So that's pretty much it with Java Math. The only other thing is that it will respect order of operations. So let's actually come in here. So I know you guys have seen that before. So parentheses, exponents, if I can type, multiplication and division. Did I spell this wrong? Yeah, I did. And then addition and subtraction. That's the order that is going to evaluate expressions in. So if we had z and that was -7, um, and we had this expression, um, let's just put in another print statement. X plus y times z. I know this trips up people all the time. They're going to want to add first and then they're going to multiply, but the multiplication comes first and then it's going to add. So let's evaluate. So right now we would expect this to be -35 plus 89. So what's that? 54. That's what we should expect, and that's what we get, 54, because it multiplies the y times the z first. So that's 5 times -7, giving us -35, and we're going to add 89 to that. So 89 minus 35 gives us 54. So that's what we have. It's not much to it. Now, with math in Java, we do have a math class that gives us access to certain methods that we can just call when we need them. It's really convenient and handy for us. I'll just go over a few examples here. So, A equals -92. All right, so we have this double here. Let's say I want to round that. Um, then the math class can help me with that. So now I'm gonna show you something here. We're gonna do A equals math dot round A. So we're gonna evaluate this and store that value into A, just like we always do with a variable. But you can have the same variable on both sides of the equal sign. That is something that you can do in programming. So it's gonna round A to the nearest whole number and then store it in A. So we can print that out. At that point, and we're gonna get -93 because -92.57 is closer to -93 than it is to -91. We can take away the negative sign and do the same thing. We'll get 93 because this number is closer to 93 than it is to 91. Okay, so that's rounding. There's absolute value. So we have int z up there as negative. So um, let's print out math dot absolute value of z. All right, so we're going to get the absolute value of Z, excuse me, and that should be 7, and we're going to print that out. And that's what we get, 7. Absolute value just gives you the distance from 0. It's like the actual value of the number. I'm sure you guys know this. And then we have minimum and maximum. So we can do minimum of y and z. Now this one requires two numbers. So remember in the last lesson we talked about methods. That's what this is, a method. This min method is belongs to the math class, and this takes in 2 bits of information, y and z, and it gets the one that's the lesser of the two, which is -7. Now if I did max, I'm going to get 5, as you can see there. This is real basic stuff. It's simple stuff, but it's really important and really useful. We did rounding, we did absolute value, max and min. Um, there are also, actually, let's just get rid of this, what we call constants in the math class. And the one that's probably the most popular is the pi constant. So it'll store pi for you and calculate it down to, let's see how many decimals, all these decimals here, and it'll print that out. So that's really useful if you don't want to just store that, you know. Now, it would be possible or sometimes better to not use this if you only wanted the 3.14 or, some other decimal location. You would, store it in a variable and use it like that. But um, it's really convenient just to have that there for you, and you can just use it in your calculations on the spot without having to type it or anything. So that's the math class. And the last thing that I'm going to talk about today, is it the last thing? There's two more things actually. So we're going to talk about equals, testing for equality or equivalence, and assigning a value. They're both represented with equal signs, but assigning a value, which is what we're doing here, up here when we create these variables, we're assigning the value of 89 to x. We're assigning the value of 5 to y. We're assigning the value of -7 to z. That's how that works. It's one equal sign. But if we want to test for equivalence, which we won't be doing until we get to if statements, but in the if statement, and I can just quickly show you an example, um, you would use two equal signs. So if x is equal to y, or we could say if x is equal to, what is it, 89, then we would print equals. Okay, we run that and we get equals because x is equal to 89. Okay, um, but if you can't do this, because this is assigning a value of 89 to x, and you can't put that in an if statement. So that's why we get the error. So we have to remember to put our double equal sign. It's something that trips up everybody sometimes. It's just one of those things. It's not a big deal. And if you're using Eclipse or some other software to edit your code, then it's going to let you know that that's wrong in the same way that you just saw that. So just wanted to throw that out there. There is a difference between equivalence and assigning a value, and it is important because it can make your code not run. All right, now there's something called logical operators, and I'm going to talk about 3 of them. Okay, now these are pretty important too, and they're basically dealing with Booleans. Remember, a Boolean is a true or a false. Okay, it's on or off, high or low, 1 or 0 kind of thing. When we talk about um, if statements in the future, other forms of, like with loops and things like that, things that go in parentheses, basically we're going to put things in there that evaluate down to a Boolean. So it's going to test the condition that you put in there and say whether or evaluate whether or not that condition is true or false. In this case, it's looking for whether or not x is equal to 89. And so if it is equal to 89, then it does this. If it's not equal to 89, which would mean this is false, then it wouldn't do this. Okay, now this is where your logical operators come in. I'll start with negation. So not or negation, and you would need an exclamation point. That's the symbol for it. So you put your exclamation point before anything that you're trying to negate. And what that simply means is you're changing the Boolean from one to the other. So if it's true, you're changing it to false. If it's false, you're changing it to true. So just to prove that to you, um, what are we on? B now equals, let's say it's false. Okay. Now, um, actually, let's say B equals not B, or the negation of B. So we're taking B, so B is false. We're negating it, so we're saying B is not B. And when it's a Boolean, it can only be the other Boolean value. So it should be true now, and we can print that out. Oops. B. And whatever, it's fine. And so we have true here. And that was false, and we negated it, and now it's true. So it's an easy way, instead of saying, instead of typing out B equals true or whatever, you can just type this. And usually you won't do it that directly, but this gives you a good way of just changing the value of that. And this can be useful here in this expression. If x does not equal 89, then we're going to print not equals. Okay. Now x does equal 89, so it's not going to print this. But if I change this to 80 and ran the code, then now it says not equals because x does not equal 89. So this evaluates the true. I know it could be kind of confusing because it doesn't equal 89. You might think it's false, but this evaluates the true because x does not equal 89. And that's what we put if x does not equal 89. So we're going to print out not equals. All right, so that's negation. And I'll do another example utilizing that, but let's get to some other examples here. So let's get rid of, let's just go skip more lines. All right, so then we have the AND operator. Now the AND operator takes two Boolean expressions, and for the whole expression to be true, both of the expressions that are being ANDed together must be true. And I realize that must have confused you, so I'm gonna show you here. So we have int c equals 0, right? So then we do if c equals 0 and, so we can't just type the word and, Java doesn't know what that means. And I don't know, c is greater than 0, which this doesn't make any sense, but this is the prove point. Then we're gonna print true, right? Okay. Now, both of these can't be true at the same time, so it's not gonna do anything, and that's the point. And with and, both expressions have to be true. So c would have to equal 0 and c would have to be greater than 0. Now, if I did, or we could say greater than -2, now we have a different result here because c is equal to 0 and is also greater than -2. So if C equals 0 and if C is greater than -2, that's just how you read it, then do this. All right? Both expressions must be true. If one of them is false, this whole thing will be false. So that's how we use ands. It's a more restrictive way of using your Boolean logic. Now we have or, and we'll just keep the same C here. If C um, equals 0 or C is less than 10, then let's just copy that. So what this is saying is just how I read it. If C is 0, if C is equal to 0 or if C is less than 10, then we'll do this. Or is inclusive in this case, which means that either one of these can be true and this whole thing will be true, even if one of these is false. So C is 0, it is less than 10, but if what if it was saying less than -10? C is not less than -10, but it still prints out to be true because C is 0. So one of these was true. It didn't matter that both of them weren't true. And that's the key difference between and or. Now, let's talk about this character real quick. This is called the pipe character. And I had never even noticed that this was on the keyboard until I started programming. But it is between the backspace key and the enter key. It's on the backslash key. If you hit shift and hit backslash, you'll get the pipe symbol. So you can use that for your ors. Again, Java doesn't recognize that. So you need to use these symbols, the pipes, the ampersands, and the knots. All right. So now back to this not though. Now we tried not equals 89 here, but what if all right. So what we have here is if C equals 0 or C is not less than 10, then print that. Okay. Now you start to see where it can get a little complicated and it can get a little convoluted. And you can also continue to add expressions. And C is greater than -14 or something like that. So these would have to be uh, true and that would have to be true for this. We're making a complicated if statement here. Um, Normally, I haven't done this too many times, but I've done stuff like this in the past. Sometimes just what the situation calls for. But I try to keep my if statements and loop conditions as simple as I can. It's always best to be as simple as you can, just because it's easier to go back and debug the code. You're less likely to make mistakes, but it can't always be simple. And that's it for this lesson. The next time we're gonna talk about um, getting input from the user, which at that point you guys will be able to actually make programs that do something. So I'll see you guys next time. Have a good one.